Welcome to AI ConvoCast, where we bring you the latest in AI and tech innovation. Quick housekeeping. Check out the affiliate links in our description. Using them supports the show, and please don't forget to rate, review, and share if you like what you hear. Let's jump right in. Today, we will be discussing Google's new Ironwood TPU chip designed for faster inference, Meta's SAM3 model that brings text-driven video object tracking to creators, and Alibaba's Qwen3 VL, which introduces massive multimodal context windows with reasoning capabilities. Google announced their 7th-generation TPU called Ironwood, and this one is specifically engineered for high-volume, low-latency inference workloads. The company says Ironwood delivers roughly 4 times the performance of the previous generation, which is a substantial leap when you consider how much inference traffic cloud providers are handling today. The chip targets real-time applications, agentic workflows, and multimodal tasks where speed and efficiency are critical. Google has optimized Ironwood for massively parallel architectures, meaning it can process enormous numbers of requests simultaneously while keeping latency down. The timing here is notable because as models get deployed at scale, inference costs and speed become the bottleneck rather than training. Google describes the chip as built for real-time thinking at scale, emphasizing that this generation prioritizes the demands of production deployments where millions of users might be hitting endpoints at once. For organizations running large language models or vision systems in the cloud, this kind of performance improvement translates directly into better user experiences and lower operating costs per query. Meta released SAM3, the latest version of their Segment Anything model, and this update brings a major shift in how video object tracking works. Instead of requiring users to click on objects to create masks, SAM3 lets you identify and track objects in videos using just text prompts. You can type what you want to track, and the model handles the rest across the entire video clip. Meta has integrated this directly into Instagram edits, making advanced video editing accessible to creators without technical expertise. The model introduces something called exemplar prompts, which allows you to match similar objects throughout a clip by specifying characteristics in natural language. Beyond social media, SAM3 is also being used in scientific visual analysis, where researchers need to track specimens or phenomena across long video sequences. The architecture combines a perception encoder with training on a large, diverse dataset, giving it robust performance across different video types and conditions. An early tester noted that this is the most creator-friendly segmentation model Meta has shipped, highlighting how the text interface removes friction from workflows that previously required frame-by-frame manual annotation. For anyone working with video content, whether for entertainment or research, this lowers the barrier to sophisticated editing and analysis techniques. Alibaba's Qwen team released Qwen3 VL, and the headline feature is native support for 256,000 token multimodal context windows. This model can process text, images, and video together while maintaining coherence across extremely long sequences. That context length is significant because it means you can feed an entire long-form videos or large document collections with embedded images, and the model retains understanding throughout. Qwen3 VL also includes thinking variants that perform chain-of-thought reasoning, essentially showing their work as they process multimodal inputs. The team addressed previous limitations by fixing positional encoding imbalances and adding explicit timestamp grounding, which improves how the model anchors understanding to specific moments in video. These improvements enable applications like long-form video comprehension, where you might ask questions about events that happened early in a multi-hour recording, or STEM reasoning tasks that require synthesizing information from diagrams, equations, and explanatory text. Alibaba designed this release with autonomous multimodal agents in mind, systems that need to perceive and reason about visual environments over extended interactions. The architecture uses a square root reweighting strategy that maintains strong retrieval fidelity even at the edges of that massive context window. Community feedback highlighted in coverage suggested that Qwen3 VL feels like the first practical long video reasoner, pointing to how it handles tasks that previously required chunking videos into smaller segments. For developers building agents that interact with visual media or research tools that need to parse complex multimodal documents, This kind of native long context support removes a major architectural constraint. The inference focus of Ironwood reflects how the industry is shifting resources toward deployment infrastructure now that foundation models are maturing. When you can run inference 4 times faster on the same hardware footprint, it opens up real-time applications that weren't economically feasible before. SAM3's text interface represents a broader trend of making powerful models usable through natural language rather than specialized skills, which democratizes access to capabilities that used to require expert knowledge. The exemplar prompts feature shows how models are getting better at understanding abstract specifications rather than requiring concrete examples for every task. Qwen3 VL's 256K context window addresses one of the persistent challenges in multimodal AI, which is maintaining coherence when inputs span long timescales or large information spaces. The thinking variants add transparency to reasoning processes, which becomes increasingly important as these systems take on tasks with higher stakes. Timestamp grounding solves a practical problem where models would understand what happened in a video but lose track of when, limiting their usefulness for temporal reasoning. These developments point towards systems that can handle more complex, longer-duration tasks without losing track of context or requiring constant human intervention to segment and manage information flow. The combination of faster hardware, more intuitive interfaces, and expanded context handling creates conditions where multimodal agents can operate more autonomously across realistic workloads rather than carefully curated demos. Thank you for listening to AI Convo Cast. Please don't forget to rate, review, and share if you like what you hear. Thanks and hope to see you again next time.